change. Later kita tengok discovery of electron, proton and neutron lah. Tapi sekarang ni summary of apa yang you perlu belajar di sini dulu untuk hari ni. For example, if you take a look open the periodic table, jadual berkala, sodium, atom tu sendiri, 11 proton, and then 11 electron. But then, when it become ion, or cation, charge positive, charge positif di sini. That means one of the electron already lost, or somewhere around, because of the reactions, it give electron to other element, so that another element become anion. Okay. That's why when it become anion, Na plus cation, sorry, not anion, ion, cation, Na plus, it losing one electron. For chlorine atom, 17 proton, 70 proton and electron, but then it gain one electron, dia terima satu elektron, dia menghasilkan Cl minus anion, ada charge di sini. Hati-hati ya. So they are different from atom chlorine to the anion chlorine. Anion chlorine ada extra 18 electron. For ions, there are monoatomic and polyatomic. For monoatomic, ions are made out from individual atoms or a type of atoms. It can be derived from a single element. Okay. While for polyatomic ion, it is a construct of two or more atoms bound together to form either positive or negative charge ion. It can derive from a group of elements which are generally non-metal, chromate, sulfate. Okay. This is a few names and a formula of some common ionic cation and anion. Kalau di Malaysia untuk student Perlis dah di UiTM, table ni quite critical. Okay. Table ni quite critical kalau di Malaysia kita. Saya tak pasti bagaimana weird. Konten untuk weird tu saya tak jelas. Okay, baik. Dekat 5 minit dah tu. 10 minit kita bergerak. Ada sedikit exercise for you. Cuba jawab untuk pelajar-pelajar semua. Kita break 5 minutes untuk student menjawab soalan. Either you type terus from a Google form here or you scan. Okay. Pilihlah yang mana satu, yang mana sesuai dengan kamu. Saya lupa untuk maklumkan kepada you all yang saya ada buat 3 exercise just to make sure you still focus for 2 hours. Okay. And then boleh daripada situ saya agak-agak lah di mana tahap pemahaman you or di mana tahap your basic chemistry. Dr. Muhammad, okey ke buat macam ni? Saya bagi exercise untuk pelajar. Baik. Untuk exercise satu ni, pada masa sama kalau ada pelajar yang nak bertanya pada saya boleh Cuma soalan tu tak berkaitan dengan apa yang kita belajar sekarang untuk waktu ni lah. Dan di sini saya juga cuba tengok dia punya participant untuk quiz satu, exercise satu, exercise satu. Setakat ni tak ada respon lagi. 5 minit saja masa diberi kepada kamu. Untuk exercise ni saya tak ada lock time. Cuma 5 minit tu diberi untuk saya continue lecture pula. Okay guys, kita sambung dengan lecture. Boleh?
Boleh, Doktor.
Alright. Okay. Yang lain yang belum menjawab soalan tu, bolehlah secara perlahan-lahan. So for atomic structure, for you, we're going to take a look on the structure itself, the isotope. Okay, only two for today lah, structure and isotope. But for when we discuss about atomic structure, we also need to understand on the electron configurations and atomic orbital, and then both theory and theory of hydrogen atoms. So why need to study atomic structure? These studies will help us to understand how the universe is constructed. At the very least, we're going to touch a bit over there. We can understand a bit about it, and how our body are made, and the component of life. Also, we can apply to other science in the field of health and disease prevention, fuel, product, industry, cosmetic, construction, and so on. So it is basically will help us to understand how we can make new things and how to utilize it. And it also will help us to avoid from something like this occur, whereby over here, a boy, this is from China, he just put a firecracker, bunga api, mercun in the manhole, lubang najis, saliran najis. Dan kes macam ni sentiasa berlaku. Then you can see from what happened over here, this is steel to over there. It's very hard to break. For structure atom, the subatomic particle, according to the atom, which atoms are not invisible. Atom can compose of three fundamental subatomic, which is a proton, neutron, and electron. Proton, neutron, and electron. The properties of particles can be summarized over here, whereby the proton, the mass dia kecil sangat, 9.1 times 10 to the power of minus 28, sangat-sangat kecil, very very small lah. And then dia charge dia, the electron, minus 1. While for proton, 1.6 times 10 to the power of 24 minus 24. And charge dia 1, positive 1. While for neutron, 0 charge. Careful, eh? So neutron saja yang 0 charge. Electron minus 1, proton plus 1 or positive 1. That's overview about atomic structure, whereby the nucleus consists of neutron and proton, and then electron was surrounding the nucleus. Electron surrounding the nucleus. But you need to understand one thing, huh? Even until today, there is no scientist that declare that they have seen or captured electron image. Okay, this hypothetical model that was accepted, the current model that was accepted. Okay, the distance between one electron to another electron there's some model about it, but in reality, betulkah ia macam tu? Saya tak tahu juga. Perhaps kalau you tertarik berkaitan dengan atomic structure, you boleh do a research related to it. So most of mass of atom, it is concentrated over here. It is the nucleus. The nucleus has a positive charge because of the proton, and a neutron has a net charge of 0 and same mass as a proton. And then the electron is carrying out the negative charge. So under atomic theory, J.J. Thomson, he said that the matter composed of particles called atoms. In early 18th, the scientist John Dalton noticed the chemical substance seems to combine and break down into substance by weight in proportions that suggest that chemical element is ultimately made up of tiny invisible particle of consistent weight. Sorry guys, saya dah tersilap letak di sini. Di sini sepatutnya gambar a picture of John Dalton. Saya tersilap copy paste. Dalton postulated that the matter is composed of very, very small particles called atom, and an atom is the smallest unit of element that can participate in a chemical reaction or change. The element consists of only one type of atom, and it has a certain mass that is the characteristic of that particular element. Okay. A macroscopic sample of element will contain incredible large number of atoms, all of which have identical chemical properties. Atoms of one element differ in properties from atoms of other element. Okay. And then compound may consist of two atoms or more elements combined in the small unit, in the small ratio, whole number ratio. In a given compound, the number of atoms of each element are always present in the same ratio. Atoms are neither created or can be destroyed during chemical change, but are instead rearranged to yield different substance or product. Okay, hasil yang berbeza. For example, kalau you ambil paper, ini eksperimen quite simple nak buat. Kertas, dan you bakar dia. Bila you bakar tu, kertas tu akan bertukar, structure dia yang besar akan menjadi makin kecil, dia akan kehilangan carbon or cellulose material, to extent dia akan jadi ash. And pada masa sama, part of it akan bertukar kepada carbon monoxide and carbon dioxide and water. But then, carbon dioxide, carbon monoxide and water ni kita tak nampak. Because when you do the experiment at your home, dia dalam keadaan open environment, terbuka. So you tak dapat nak connect water dengan carbon monoxide. Dalton used a three law of chemical reactions as a base for his theory. The first one, the law of conservation of mass. The second one, the law of definite proportions and multiple proportions. The Dalton theory provides a microscopic explanations of many macroscopic properties of matter. First one, conversions of mass. Conversion of mass ni masih dipakai sehingga sekarang lagi. It was first discovered by Anthony and whereby he stated that the total mass present before a chemical reactions, it is the same as the total mass present after the chemical reactions. Okay. Kalau kamu nak ingat, quite simple lah. Apa yang kita makan, itulah yang keluar. Dan memang betul, bila keluar tu tak adalah sama berat. Sebab because part of it, ianya makanan tu dah ditransform pada energi. Dan mungkin juga dah menjadi lemak. Makin berat, dia akan jadi kolesterol. Macam saya ni seorang yang kurus, memang tubuh memang kurus secara genetik. So, banyak kolesterol dalam tubuh. Walaupun makan sikit ke, walaupun menjaga makanan pun. Dia tubuh tua. Dan genetik juga sekali. So, atom neither create nor destroy during chemical reactions. So, wood, for example, you nak bakar dia, wood, you perlukan oxygen, and then dia transform into ash, carbon dioxide, and water. Okay. The total mass of wood and oxygen equal to the mass of ash plus carbon add with the carbon dioxide and water. Not carbon, carbon dioxide and water. Same thing like energy. Energy before must be equal to energy after. Ini you pakai formula ni, you akan pakai untuk unit operation pun sama juga. Mass balance pun sama juga bila buat nak balas. Sebenarnya, follow constant composition or definite proportion formulated by Joseph Proust, whereby it said that if a compound is broken down into a constituent elements, the masses of constituent will always have the same proportion regardless the quantity or source of the original substance. Okay. So macam mana ni, saya alhamdulillah boleh jumpa quite nice video. Okay. Okay, alright. Kita continue ya. Law of multiple proportion is stated that when two elements combine with each other to form a more than one compound, the weight of element that combine with a fixed weight of the other are in ratio of small whole number. Nisbah nombor terkecil. It was announced by John Dalton, and its confirmations for a wide range of compounds serve as most powerful argument in support of the Dalton theory that matter consists of invisible atom. So atom ni tak nampak ya. So yang ni law by multiple proportions. Okay, baik, kita start ya. So, pelajar semua, you all boleh tengok balik lah yang ni. Kita dapat full spectrum related to the multiple proportion ni. There are another example. Then the video ni ambil masa lebih kurang 11 minit. It's quite long. So, kita continue dengan kita punya task kita lah. And then the discovery of the electron, J.J. Thomson, yang tadi tu gambar eksperimen tu, saya tersilap tu, began experimenting the cathode ray tube, CRT, whereby he established the ratio of mass to electrical charge for cathode ray. He concluded that, dia buat kesimpulan that bahawa cathode ray are negatively charged fundamental subatomic particle. Yang particles ni can be found in all atoms. Okay. Later cathode ray ni known as electron. Okay. Yang ni the terms electron introduced by G. Stone 1874. Okay. Discovery, productions and the properties of cathode ray, if you are interested, you can go to the YouTube. Yang ni agak panjang sedikit yang tu. Then in 1911, Ernest Rutherford report that atom is made of a central charge known as atomic nucleus, and it was surrounded by the cloud of orbiting electron. Ini very interesting experiment. Eksperimen ini dia buat kembali, discover balik macam mana Ernest Rutherford tu jumpa elektron. Reconstruction. Untuk yang ini, idea ini yang di mana elektron dengan proton embedded in the just like a cake daripada John Dalton. So Rutherford dia nak check betul atau tidak hipotesis yang ni, model ni.
The electron is very important.
Ini schematic diagram dia. Dan eksperimen ni sendiri pun saya tak pernah buat. Dan please guys, eksperimen ni agak berbahaya because you cannot see the electron, and it is possible kalau you terdedah dengan kandungan elektron yang tinggi atau alpha yang tinggi, you boleh kena cancer. That's why a lot of researcher yang lama-lama dulu yang study berkaitan dengan elemen ni, diorang ni tak kaya. Memang tak kaya. Dan kematian diorang disebabkan, banyaknya disebabkan oleh kanser. So the proton and neutron, discovery of it, 1990, Rutherford discovered the particle that he called it as a proton. He studied, and in the study involving the scattering of alpha particle by the nitrogen atom in air. The Rutherford also predict the existence of nucleus with no charge or neutral. Yang tadi yang awal-awal slide kita tu, yang berkaitan dengan proton, elektron, neutron, dia punya charge tu, inilah yang discover dia. These neutral particles are discovered by James Chadwick in 1932. James Chadwick tu. Kalau you tengok di situ, saintis ni, nak jadi saintis, kepala dia, asas dia kena botak sedikit. Hilang rambut sedikit. Stres berfikir. Maksud saya lah, saya masih ada rambut lagi, nasib baik. Masih handsome lagi lah. Symbol for atomic number is Z. Dan bergantung kepada type of books that you use. You can redefine balik. Atomic number ni, if some books use X pun boleh, no problem. And there are difference between one book to another books between the symbol. Because bila you nak publish books, you tak boleh nak guna benda yang sama. Itu dipanggil copyright infringement. And then the atomic number Z equal to the number of proton and number of electron in a neutral atom. So atom in a neutral, Z equal to the number of proton equal to the number of electron. For each element, it has its own atomic number, which means that all atoms of the same element have the same number of proton. For example, this one, sodium, Na, again, atomic number dia 11, thus the atom of sodium 11 proton, electron pun 11. Okay, atom. Aluminium, Al, the atomic number 13. So all the aluminum atoms consist of 13 protons or 13 electrons. So some atomic mass in the periodic table, but then some atomic mass in periodic table, it is not whole number. I mean, it could be 35.5 or 41, 41.2, and so on. So why it become like that? Okay, let's take a look. Sorry. Relative atomic mass for each element ni kita boleh identify or kita boleh measure it using mass spectrometer. Okay. Whereby by using mass spectrometer kita boleh isolate isotope and berat dia. Okay. Isotope dan berat dia, and then kita can recalculate back the means of the element. Seperti contoh sebelum ni lah. Okay. So because atom ni dia akan sentiasa ada elektron. Okay. Dia sentiasa ada elektron. When you should you keluarkan elektron tu, push the electron of atom tu keluar. So dia akan bergeraklah ke hadapan. Kedudukan dia, or you can divert the position of the electron that we go to. That means you boleh buat, electron ni, you shoot it over here, but then suddenly you want to change the direction. If you want to change the direction of electron, you can apply a positive charge or positive plate or magnet. Magnet lah, dia pakai magnet. Which one? North one. Okay. Because magnet ada south and north. Itu konsep dia. Bolehlah buka Google or buka buku related tu mass spectrometer. So again, any critical for you, it's very critical ni. Ramai student saya buat kesilapan. Bukan student saya. Saya ni, ini basic chemistry ni dah 8 tahun saya tak mengajar. Dah lama saya tinggal. That's why I need help from Madam Azira untuk bagi good feedback. Apa yang sepatutnya saya expect from a student lah. That means student tu, student UiTM. Hopefully student UiTM more or less the same with you lah. But it seems that from your performance ni, student daripada Indonesia ni lagi bagus. You all ni lagi bagus daripada student UiTM. That's great lah. Good one. Clap your hand. Clap your shoulder. That shows how good you are. Kita nak tepuk tangan pun tak ada siapa dengar kan. Nanti terkejut mak ayah kamu nanti di rumah. Okay. Yang ni very critical. Ini konsep asas dia. For atom, dia ada mass dia. And proton number dia. Okay. So proton, for atom, proton equal to electron equal to Z. Doesn't matter the number of Z. But then, if the X sekarang ni, elemen X ni, ada charge. So, kita nak tengok number of electron. Ya guys, jadi proton tak keluar, susah sangat. Proton untuk keluar. Kebiasaannya reactions, elektron yang keluar atau bertindak balas dengan other electrons. Tindak balas tu biasa berlaku disebabkan oleh electrons. That's why later on you akan belajar electron configuration. Ini proton. Proton state untuk ion ni still Z. Number dia sama je. Kalau 10, 10 dah ia. But then number of electron dia berubah dah. Because proton equal to electron plus charge dia. Charge di sini lah. So P electron equal to P minus charge, and then neutron A minus P. So A equal to the mass number, P or Z equal to the number of proton, and neutron number, and then E equal to the electron. Ini example, simple example. One of it is atom. Okay. Sodium. Oh, dia ada perubahan dah sikit di sini. Sepatutnya Na ni, A tu small. Dia sepatutnya macam ni. Buat di sini lah. Sepatutnya dia jadi macam ni. Okay. Dia 311. Mungkin semasa saya save tadi dia ada berlaku perubahan yang saya tak perasan. P proton, up to you, you nak pakai capital or small letter pun boleh. Z pun boleh juga. Kalau you nak Z tu kecil pun, small letter pun buat kecil pun boleh. Equal to 11. Electron 11, neutron A minus P, which is 23 minus 11, you akan dapat 12. And then magnesium, proton dia 12, and then electron dia 10, neutron dia 12. Okay. Yang ni you boleh try sendiri lah. Okay. Boleh try sendiri. Dan self-assessment. Ini kekurangan sedikit berkaitan apabila kita punya talk tu menggunakan Gmail. You kena banyak buat self-assessment. So sekarang ni kita akan pergi kepada isotopes. The number of proton in nucleus of atom can be determined or calculate the identity of the atom. As a result, all atoms of element must have the same number of protons, but they do not have to contain the same number of neutrons. Atom with the same number of neutrons but different number of neutron, same number of proton but different number of neutron is called isotope. Saya lupa ladies, guys. Bila saya membaca ni saya suka tengok di bahagian hujung dulu. Yang ni disebabkan latihan yang saya buat speed reading. That's why kalau you perasan, saya tertukar perkataan proton ni tadi dengan neutron. Kesan sampingan speed reading. Sepatutnya speed reading dibaca kata-kata tu kata tu tak keluar. Tapi bila dua-dua dibuat, dia akan lari sedikit. Okay, so sorry about that. Dah terbiasa. So atom ni again, atom it is a same number of proton but different number of neutron, and we call it as isotopes. Okay. It also can be defined as atom with have the same atomic number but different mass number. So similarity between isotope and atom, and difference dia. Similarity dia untuk isotopes, dia punya atomic number, proton number and electrons, and dia punya chemical properties. Okay. But then the difference dia, kita tengok mass number dia berbeza, neutron and physical properties. Hydrogen is a very famous element, hydrogen.
This lesson looks at why some isotopes are radioactive. You may wish to refer to the lesson Why Aren't We Stand video. The identity determined by the number of protons. Atoms get bigger and heavier. Nuclei glue hold them together. Neutrons provide something called strong nuclear force. Elements can exist with slightly different numbers. Isotopes. It is a common heavy element. Lots of neutrons are required to hold them together, but smaller, lighter elements give you isotopes of hydrogen. Hydrogen 1, 2 also they have 0, 1, 2 respectively. Tritium is the heaviest isotope. It has a larger mass number. Note that in each of these isotopes is a single proton. This means that the element is unchanged. It's an important point. It is still hydrogen. It reacts exactly the same way. There is often more than one stable isotope. The Brangus, the other stable isotope. Sometimes too many for it to be stable. An analogy is a person carrying boxes. If you try to carry too many boxes, you'll end up dropping some. Continue, you'll keep dropping boxes until you. This is your stable state. Nuclei, similar way, will try to stabilize themselves. If there are too many protons, the nucleus can spontaneously rearrange itself, throw out particles in the process. This is essentially what happens in radioactive decay. Isotopes that unstable nuclei known as radioactive isotopes or radioisotopes. In our hydrogen examples, tritium are unstable and are hence radioisotopes of hydrogen. The more unstable a nucleus, the faster it will try to rearrange itself into a more stable state. Another name for this process is radioactive. Radioisotopes are often used in medicine to trace aspects of body chemistry or blood flow. For example, a small amount of radioisotope technetium-99 may be injected into the bloodstream to show up on medical imaging and X-rays. This is known as a medical tracer. Tracers can be used by chemists to understand how a reaction works.
Prof, suara
Ya.
videonya bisa dibesarkan.
Ya, apa dia?
Suara video yang diputar itu bisa dibesarkan.
Oh, okey.
Karena tidak terdengar.
Oh, di sini dia tak dengar ya? Oh, dia bergantung kepada saya. Okey. Sekali lagi kot.
Oke.
Boleh sekali lagi kah?
Boleh, silakan, Prof.
Okey, sorry. Saya tak...
Why aren't all atomic masses whole numbers? To help you understand this video. The identity and chemical properties of any atom are determined by the numbers of protons in its nucleus. As atoms get bigger and heavier, the nuclei get bigger and heavier, and the protons need a sort of nuclear glue to help hold them together. Neutrons provide this glue and prevent the positive charges of protons from repelling each other, thanks to something called the strong nuclear force. Elements can exist with slightly different numbers of neutrons, and we call these isotopes of an element. It is particularly common for heavier elements where a lot of neutrons are required to hold the nucleus together, but smaller and lighter examples include the isotopes of hydrogen. Hydrogen 1, hydrogen 2, also called deuterium, and hydrogen 3, also known as tritium, are the three isotopes of hydrogen. They have 0, 1, and 2 neutrons respectively. Tritium is the heaviest isotope of hydrogen as it has a larger mass number. Note that in each of these isotopes there is a single proton. This means that the element is unchanged, and that's the important point. It is still hydrogen and will react chemically in exactly the same way. There is often more than one stable isotope of an element. In fact, much of the world around us is made up of stable isotopes. However, sometimes there aren't enough neutrons in a nucleus, or there may be too many for it to be stable. An analogy is a person carrying boxes. If you try to carry too many boxes, you'll end up dropping some. And if you continue, you'll keep dropping boxes until you reach a manageable amount. This is your stable state. And nuclei behave in a similar way, and they will try to stabilize themselves. If there are too many protons or too many neutrons, the nucleus can spontaneously rearrange itself and throw out particles in the process. This is essentially what happens in radioactive decay. Isotopes that have unstable nuclei like this are known as radioactive isotopes or radioisotopes. In our hydrogen examples, tritium are unstable and are hence radioisotopes of hydrogen. The more unstable a nucleus, the faster it will try to rearrange itself into a more stable state. And another name for this process is radioactive decay. Radioisotopes are often used in medicine to trace aspects of body chemistry or blood flow. For example, a small amount of the radioisotope technetium-99 may be injected into the bloodstream to show up on medical imaging and X-rays. This is known as a medical tracer. Tracers can be used by chemists to understand how a reaction works. Atoms of radioisotopes can act as markers, allowing chemists to follow how a reaction sequence occurs. And of course, radioisotopes are also used in radiotherapy to kill malignant cancer cells. So, as you can see, isotopes are important in modern science. and so we'll finish with a summary of the key points. Isotopes of the same element have the same chemical properties. Some isotopes are stable. Isotopes that are unstable are radioactive. Radioactive isotopes are also known as radioisotopes. Radioisotopes can be used as tracers or markers in chemistry and medicine, and they are also used to kill cancer cells.
Okey. Tadi terangkan kembali volume. Right. And then the best part is that from from isotope ni, elemen with isotope ni, especially uranium, we scientists sufficiently develop a technology to convert it into energy. So from there, kita dapat energi yang sangat murah berbanding dengan solar energy atau kita panggil hydro energy. But nuclear energy ni, tak semua negara boleh atau sesuai untuk set up nuclear power plant. Sebagai contohnya, di Malaysia sepatutnya by 2070 itu sepatutnya kita dah ada satu nuclear reactor untuk power supply di Semenanjung dan di Sabah Sarawak. But then because of political sedikit ada isu-isu melibatkan alam sekitar and so on, mereka melihat benda nuclear fissions atau nuclear reactor ni tak bagus. Sedangkan kalau kita, negara nak maju, kita at least perlukan tenaga kerja yang mahir, yang ramai. Itu satu, aset kepada negara. Keduanya, tenaga dari segi electricity yang murah, and then kawasan lah, land lah. Seperti mana saya tengok Perdana Menteri Indonesia yang saya lupa dah nama dia. Siapa nama apa dah? Pak Suharto, bukan Pak Suharto. Nama apa Perdana Menteri Presiden Malaysia? Presiden Indonesia?
Jokowi.
Oh, Jokowi, ya, Jokowi. Jokowi very clever. He tried to shift, or he already shift the city or main city to the section of Borneo. Itu kawasan yang sangat besar. Dan kawasan itu tak terganggu dengan gempa bumi. So dia selamat di situ. Very good. Very clever guy. So for nuclear fissions, banyak negara yang maju, semualah negara maju menggunakan nuclear fissions.
Unstable radioactive nuclei, which occur naturally, sometimes emit strong radiation, especially in isotopes of uranium like uranium-238 or uranium-235. The disintegration converts the uranium isotope into stable lead, and in the process emits energy in the range of 1 to 5 mega electron volts. That's 1 to 5 million electron volts, and even higher amounts of energy can be released by breaking unstable nuclei into even more parts. In 1939, a German scientist named Otto Hahn discovered that breaking up the nucleus of uranium-235 into 2 parts emits 200 million times the energy of the neutron which triggered it. He, along with his 2 colleagues, Lisa Meitner and Fritz Strassmann, found that when the nucleus of uranium-235 is bombarded with neutrons, it will absorb one of the neutrons. This results in an unstable compound nucleus, and the nucleus breaks into 2 equal parts. This process is referred to as nuclear fission. So, a process in which heavy nuclei are bombarded with neutrons and split into two equal masses, releasing enormous amounts of energy, is called nuclear fission. In the process, uranium-235 initially absorbs a slow-moving neutron, thus forming a highly unstable
Ini proses conversion of energy.
uranium-236. This is what
Di mana
triggers
mass
the nuclear reaction.
energi sebelum sama
During the
dengan energi
process of
selepas.
fission, uranium-236 splits into two product nuclei, which are barium-141 and krypton-92. You should notice that a barium atom has 56 protons and a krypton atom has 36 protons, which add up to the uranium atom's 92 protons. The unstable uranium-236 nucleus also releases 3 neutrons in the process. This happens because barium-141 has 141 neutrons and krypton-92 has 92 neutrons, adding up to a total of 233 neutrons. To balance the equation, uranium-236 must emit 3 more neutrons. The chemical equation of the nuclear fission reaction taking place can be represented by this equation. So as you can see from the equation, 1 neutron combines with uranium-235, forming an unstable compound nucleus, uranium-236. This unstable nucleus splits into 2 stable nuclei, barium-141 and krypton-92. In addition to these 2 nuclei, 3 neutrons are also emitted, as well as a high amount of energy denoted in the equation by Q. Since uranium-236 emits 3 neutrons in the reaction, these neutrons can be absorbed by other uranium-235 nuclei, resulting in a chain reaction. This leads to exponentially high amounts of energy being released by a single reaction. So, in this video, we've covered that nuclear fission reactions result in massive amounts of energy being released. Now, these nuclear reactions are most well known for the part they play in nuclear bombs, but they are also an essential part of nuclear reactors, which have the capability to provide mass amounts of energy with relatively low cost. But that's a different topic altogether. In this video, we're going to talk about
Badan bila you ada reaktor nuklear, ada possibility reaktor tu untuk meletup. Sekiranya meletup, dia akan jadi seperti just like Fukushima. One whole city tidak boleh dihuni, terdedah dengan radioaktif material. Mutation berlaku pada plant, pada tumbuhan, pada haiwan dan ramai yang menghadapi penyakit kanser, leukemia. And then for you yang paling bahaya sekali sebagai engineer dalam petroleum, at the very least kan, you kena ada target lebih kurang 15 tahun saja untuk bekerja di petroleum punya industry, and then later on retire. Why? Because this.
Think of the biggest secret of the past century, the biggest lie. This is bigger. My name is Justin Noble. I'm a science journalist. I write about issues of science and the environment for US magazines and investigative sites. And for the past 2 years, I've been researching the issue of oil and gas radioactivity. And so one of the first revelations is that oil and gas production brings with it to the surface an incredible amount of radioactivity. Much of it comes in the form of a toxic, salty liquid that the industry refers to as brine. Brine is something that collects at a wellhead in tanks, and human beings, truck drivers, must pull up to a wellhead and pick the brine up and take it to a site for disposal. These drivers are completely unaware that they are handling a hazardous substance. They're told they're hauling water or salt water, when in actuality, they're hauling something that well should be labeled as radioactive. And we can look at numbers In the US, we often measure radioactivity with a unit called picocuries per liter. Environmental Protection Agency is our agency to look after our health, and they have a limit, a safe drinking water limit for radium, which is this very hazardous radioactive element in this brine that these truckers are picking up. Their limit is 5. The Nuclear Regulatory Commission has an industrial discharge limit, and there's 2 different isotopes of radium. Their limit is 60 for each isotope. And the brine that these truckers are hauling, radium can be as high. Alarming and terrible discoveries in my research is to discover that there was a set of Louisiana legal cases in 2016 in which oil and gas workers working a variety of common industry jobs developed lymphomas, leukemias, colon cancer, liver cancer, and other types of cancers. Many of them died, and their exposures were linked using an analysis program created by the CDC, part of the US government. Their exposures were linked indisputably to the radioactivity exposure they received on the job. We only know about these cases because in Louisiana, they were brought in front of a court of law. There is no way that this is not happening in other parts of the country, in other parts of the world.
Baik. Oleh kerana you pilih dah program untuk petroleum ni, sure, at one time you akan bekerja di kilang petroleum ataupun pusat cari gali, Exxon, Shell, Petronas, or other company lah. Okay, offshore, inshore, depend on the you punya peluang kepada kamu untuk bekerja. So bila bekerja kita biasa tidak boleh nak memilih kerja. Okay, itu satu lah. And then let's say you bekerja juga di kilang petroleum. Situasi ini memang berlaku, memang ada. Dalam petroleum itu sendiri memang dah ada radioactive material. So how to protect yourself? Advice daripada profesor saya, Ismail Abdul Rahman, Prof. Ismail, dia bagi tahu kalau bekerja dalam kilang atau industri related atau chemical, just like you all and me, bagusnya jadikan praktis minum susu segar. Okay, minum susu segar, and then you pergi ke farmasi, dia ada tablet charcoal. Tablet charcoal ni berbeza dengan arang di luar, arang yang kita guna untuk membakar. Tablet charcoal ni dah diproses. Tablet charcoal ni nanti dia akan absorb radioactive material atau elemen yang berbahaya kepada tubuh kita, dan later on kita akan keluarkan through macam biasalah, secara naturally. Baik. Dah tengok video, kembalilah kita kepada exercise yang kedua. Dia ada 3 exercise, jangan risau. Okay, you boleh start exercise. Dan kita akan another 5 minutes. Kita akan teruskan lecture ni. Dr. Muhammad, okey ke ada banyak exercise ni?
Ya, Prof.
Okey ke? Banyak exercise kepada budak ni?
Nggak ada masalah, Bro.
Tak ada masalah.
Because saya juga minggu ini memang free lecturing, jadi full from Prof gitu.
Okey. Nanti result daripada student exercise ni saya hantar kepada you lah. Untuk you nak,
Boleh, Prof.
untuk you kalau you nak guna ke apa-apalah yang sepatutnya.
Oke, terima kasih Prof.
Sama. Ada juga apa lagi? Apa dah?
Prof,
Ya, saya dengar. Ya, ada apa?
mungkin untuk data hasil exercise-nya mungkin bisa Prof kirim ke saya dalam 2 atau 3 hari ke depan. Karena abis ini saya akan Google Meet-nya, video conference-nya akan saya share ke mahasiswa yang lain yang tak bisa hadir di
Oh.
video conference ini.
Oke.
Terus nanti pasca after itu saya akan share, terus saya suruh mereka kerjakan soal ini, otomatis akan masuk. Saya beri waktu 1 atau 2 hari, mungkin di hari ketiga lepas nih baru Prof bisa kirim ke saya supaya semua mahasiswa dapat kesempatan yang sama gitu, Prof.
Betul, bagus tu, Saya, berapa bilangan student ni, pelajar ni? Mahasiswa ni?
Pelajar ini tahun angkatan ini ada 180-an orang, Prof.
Masya Allah,
Plus
ramai
ada
ni.
yang ngulang, yang udah semester 7 berapa gitu, mungkin dulu nilainya agak dirasa kurang, terus ngambil lagi gitu.
Oh gitu. Di UIR boleh ulang lagi ya? Kalau rasa tak puas hati ya?
Belum lepas hati bisa ulang.
Oh, bagus tu
Contoh
sistem tu.
contoh bila dulu mereka dapat grade C,
Ha,
because mungkin entah ujian atau ada tugas atau
ya.
exercise yang kurang,
Hmm.
ada tugas exercise yang kurang, maka mungkin nilai kumulatifnya bakal kurang sehingga dapat nilai C atau
Ya.
B- dan lain sebagainya. Nah, jika mereka ingin perbaiki to upgrade nilai, nah bisa diulang gitu, Prof.
Itu konsep yang bagus tu. Saya suka tu. Kalau di
Iya.
UiTM, kalau pelajar tu C lulus, dia
Ya.
tak boleh ulang dah. So,
Oh, tak boleh ulang ya,
tak
Prof.
boleh ulang. Walaupun selepas tu dia rasa nak mengulang tu, rugilah kepada student. Kerana kalau saya tengok,
Iya.
walaupun belajar tu masa ambil nama, yang pentingnya cumulative grade tu tinggi. Bagi saya itu yang paling penting. Kalau boleh ulang
Ya,
kali tak ada
benar.
masalah. Bagus menurut saya.
Iya.
Bagus. Biasalah.
Oke, Prof.
Kita pun dulu doktor, kita pun muda juga dulu. Kadang-kadang tu ada masa kita malas sedikit.
Iya, benar. Ya, down gitu ya, Prof ya.
Biasalah. Manusia kan memang macam tu. Ada ketika saya
Iya,
dulu pun
benar.
sama juga. Ada ketika rasa nak bercinta, bercintalah ya.
Iya.
Lepas tu dah matang sedikit, tengok, susahnya nak cari kerja. Kalau
Kerja.
graduate dengan CGPA rendah kan, cumulative grade rendah,
Iya,
cancel
benar.
cinta.
Iya, betul. Terima kasih, Prof.
Okey, sama. Bagus tu, sangat bagus. Sistem yang bagus. Baik, kita teruskan. Exercise ni you boleh buat dan submit lah bila you rasa dah satisfied dengan jawapan kamu. Kemudian problem dia dalam basic chemistry ni yang student saya hadapi lah, student di Perlis. Saya tak jelas dengan situasi kamu. Kebiasaannya student are not able to name the compound. And then situation become worse. Let's say that you were given the name of a certain compound, but you cannot transform it into a formula, the right formula for that particular compound. So di sini notes related to naming of compound bit of notes related to naming of compound, and then how to get the right formula for a few compound. Kalau you rasa siswa rasa sesuai, notes ni membantu, gunakanlah, insyaAllah. Dapatlah sedikit sebanyak pahala untuk saya. When we talk about atom, the more critical part are atomic mass unit, concept, or mole concept, whereby based on atomic mass unit, relative atomic mass, and relative molecular mass, and the relationship between moles and mass, also the relationship between the mole, Avogadro number, and calculate the percentage composition of the compound, and also empirical formula and a molecular formula. Hopefully, because kita punya time agak constraint hari ni sekarang ni dah 11.24. Kalau kita bernasib baik, kita akan pergi ke at least atomic mass, until atomic mass, yang ini, and then relative atomic mass, and also bit of mole and mass relationship. Atomic mass again, it is the mass of atom in the atomic mass unit, AMU, which is 1 AMU equal to 10 to the power minus 24 gram, which is equivalent to or setara dengan 1/12 mass of carbon 12 atom. Okay. So 1 gram of carbon equal to 6.02 10 to the power 23 AMU, atomic mass unit. Based on periodic table, the mass of hydrogen atom can be represented as below. And then the actual mass of hydrogen is 1.6 times to the power of minus 24 gram. Very, very small. Even until today, kita tak ada penimbang yang boleh timbang 10 to the power of minus 24. So all this number mean the calculated number sahaja. Setengahnya guna theoretical number. Tapi kita consider it as actual mass. Perhaps another 20 years, kita boleh timbang mass of hydrogen atom. Hopefully lah. So, mass of one carbon 12 atom equal to 12 AMU. So it is equal to 1.96962 times to the power of minus 23 gram. Therefore, equal to 1.66 times to the power of minus 24. Bila you divided 1.99 to the power of minus 23 with a 12, you dapatlah 1.66 times to the power of minus 24. Therefore, 1 gram equal to 6.02 times to the power of 33 AMU, kuasa 23. So for relative atomic mass of element equal to the mass of one atom of the specific element times the mass of one of carbon 12. So atomic mass of all elements in periodic table can be determined by comparing it with the mass of carbon 12, which we call it relative atomic mass. Relative kadaran. Relative atomic mass for certain elements, for example, nitrogen, 14, sodium, 23, bromine, 80. So for relative atomic mass, you need to be very careful. It is the sum of relative atomic mass of all atoms in the chemical formula. Okay? chemical formula. So chemical formula ni, the basic dia, asas dia, you should be able to name the formula and to write the formula. Kalau di situ you tertinggal, susah dah untuk kamu. Susah untuk kamu score untuk subjek ini lah. For example, sulfuric acid. This is sulfuric acid. H2SO4. That means from the H2SO4 ni, you know that there are two atoms of hydrogen. One atoms of sulfur and 4 atoms of oxygen. That's why you boleh write something like this. 2 in bracket relative atomic mass of hydrogen plus 1 relative atomic mass of sulfur and add with 4 relative atomic mass of oxygen. So, ini hanya menggunakan kalkulator sajalah. Dan please berhati-hati. Tipikal kesilapan dia, student saya juga ni careless mistake. Student dah berjaya dah. Write the right formula for the compound. And then dah manage to identify dia punya number of atom number of element in a compound tu. Okay, very good. But for some reason, yang saya tak ketahui macam mana, atau lalat or cuai, daripada 89 dia jadi 98 dia jadi 89. From 98 to 89. Ni kesilapan ni ramai sangat student saya buat. Kesilapan ni will cost you a lot of marks. Rugi sangat-sangat. Sayang. Another example, copper sulfate pentahydride. This is a formula dia. 1 copper and 1 sulfur. Saya tukar color. Ya. One atom of sulfur, and then four atom of oxygen, and yang ni special sikit. Kalau you tengok di sini, ada not di sini. Not, it means that after not ada 5. So it means that then ada molecule. Ada 5 molecule of H2O. So because of that, you kena buat macam ni. And then you kena ada bracket di sini. Bracket ni adalah H2O. 2 hydrogen, atomic mass dia adalah 1 for hydrogen, and for oxygen only 1 oxygen, atom oxygen for H2O 60. Dan dia akan dapat macam ni lah result dia. Kesilapan dia, tipikal kesilapan, mistake by a student. Oh, sorry. By my student. student saya lah. Okay. Nah, kita tengok. 5 ni, dia buat macam ni ya, di sini ya. Saya show sini. 5 in bracket 2 1 hydrogen, stand for hydrogen. So 2 ni relative atomic mass for hydrogen. To 16. Bila when you do this kind of simple mistake, it change the number over here. Big change, very very big change. Okay. So berhati-hati. Buatlah exercise. Jadi you kena sentiasa buat exercise ya. Then molar mass, whereby the molar mass equal to the mass of 1 mole of substance in a gram. Molar mass has a unit of gram per mole, but then for relative molecular mass, it has no unit. Okay. So when you calculate calcium nitrate, bila dihitung calcium nitrate, yang ni konsep yang sama juga. Perbezaan dia di sini you kena tengok trik dia di sini. Kesilapan yang biasa dibuat, pelajar lupa makna 2 di sini. The meaning of 2 over here. It means that there are 2 NO3 plus NO3, okay, minus. So, itu maksudnya dimasukkan oleh structure ini. Yang ni latihan ni you kena buat from the naming of compound and then how to write the right structure for the compound. Okay. Bila you tahu yang tu, dah biasa dengan ini, familiar with it, secara langsung you tahu 2 ini, it means 2 over here, and then in bracket the element inside it. Okay. Number of atoms inside it. So the molar mass for calcium nitrate 164 gram per mole. So 1 mole equal to, ini penting ya, sangat penting ni. Very important. 1 mole equal to 6.022 times 10 to the power of 23 particles. That means the particle could be ion, atoms. If ion, it could be an ion or cation, atoms or molecules. So this number called Avogadro number. Okay. And then from the test yang kamu buat tu, saya buat 10 to 23. Saya menggunakan simbol ini ya, yang menunjukkan 23 is the power of it, power of 10. Ini kekurangan dari sudut Google Form. So tak boleh nak buat apa. But still, tanya, you all managed to obtain, most of you managed to obtain 35. 34 or 34. Full marks. Ramai sangat mendapat full marks untuk exercise 2. 82 pelajar siswa yang mendapat markah penuh untuk exercise 2. But then you need to remember, exercise yang saya bagi itu adalah asas sahaja. Itu asas sahaja. Mesti saya design exercise tu pertamanya nak build up confidence pada diri kamu. You should be able to confidence supaya you tak takut dalam polymer atau basic chemistry ni. Okay. And then bila you rasa tak takut dan you rasa benda ni quite simple and easy for you to absorb other information or knowledge related to basic chemistry. Yang penting, konsep dia. Okay. Yang mana yang rendah tu, that means you try. Kecuali, you try sahaja. Dan kecuali ini sukar untuk lecturer bantu, kecuali kamu sendiri cuba membuat exercise yang lebih banyak lagi. Itu saja pilihan kamu. Therefore, ways to calculate the number of mole, either using a mass or molar mass, or from the Avogadro number, or based on volume or molar volume. Okay. Right. And then using the molarity and volume. Right, guys. Doktor, macam mana ni, Doktor? Doktor Muhammad? Perlu saya continue lagi ke kita nak stop di sini? Pasal sekarang ni sekejap guys, saya nak tanya Doktor Moderator, Dr. Muhammad, you punya lecturer. Oh, okay. Dr. Muhammad. Sambil kita tunggu. Oh, lanjut Pak. Ada kawan kamu minta suruh lanjut kan? Masih okey lagi you all lah? Masih boleh terima lagi? Oh, okey.
Next Pak. Next.
Next, saya boleh proceed Alhamdulillah. Kalau tak boleh proceed, bagi tahu. Baik, kita continue lah. Mass equal to the mole equal to the mass of substance in a gram. Hati-hati ya. Unit dia gram. And then divided with the molar mass of substance, gram per mole. Kesilapan dia, typical mistake, student tak convert. Perhaps your soalan tu from milligram or kilogram. You just direct use the number. Let's say 10 milligram. Direct terus kamu pakai. Sebenarnya sedangkan 10 milligram over here, it change to 10 times 10 to the power minus 3 kan, milli kan, gram. Barulah you boleh divided with the mass of substance in a gram per mole. Again, same thing, same compound, ionic compound, calcium nitrate. Let's say the mole of calcium nitrate equal to 0.432. So calculate the mass of it. At first, for sure, you kena write the right formula for calcium nitrate, and then you need to calculate the relative atau molecular mass of calcium nitrate. Okay. From there you dapatlah ni, and then mole you ada untuk kes yang ni, calcium nitrate ni, kes you akan dapat macam mana ni, 0.432 equal to mass divided dengan 164. Ini hanya matematik saja. 70. Or you can rearrange ini. Dia become like this. And then the particles, number of particles, ion, cation, that could be cation or anion, or atoms or molecule, equal to moles times the Avogadro number and number of particles in the formula, in the molecules tu lah, or in the compound tu. So, number of ion, perubahan dia sedikit saja, ion saja. Particles ni ditukar dia kepada ion, yang mana number of moles times the Avogadro number and number of ion in the formula. While for the atom, if you are interested in the atom, number of mole times the Avogadro number and number of atom, and so forth with the number of molecule of the formula. Just example, sodium chloride, garam, salt. Okay. Information yang diberi kepada kamu for this case, simple one, 15 gram of sodium chloride, 15 gram of sodium chloride, and then you need to calculate dia punya moles. Okay. From predicate table, you boleh dapat nilai untuk sodium chloride, for chlorine, for sodium, for chlorine 35.5. So for sodium, dia ada 48, maknanya berapa tu? 3, 23. 23. Okay. And then I just use a calculator. You akan dapat 0.26 mole. While let's say you need to calculate the number of molecules and number of atoms in the 4 mole of ammonia, NH3, the number of atoms per molecules or molecules equal to the number of the mole equal to the mole. Macam mana nak kira number of atom dia? Avogadro number, yang ni dah fix dah. Yang ni you kena calculate ni. Calculate or depend on the soalan lah. Yang ni dah diberi, you direct boleh tukar, boleh tambah di sini. And then number of particles in the formula. Okay. So for the number of molecules, if you calculate the number of molecules, if it require you to calculate number of molecules, dia ada satu molekul saja, NH3. So 4 mole times Avogadro number, ini fix. Jangan tertukar, jangan lupa untuk hafal. And then satu molecules, you akan dapat directly 2.41 times 10 to the power of 34. But then, number of atom in a molecules, for this case NH3, moles still sama, based on soalan given to you. Avogadro number fix, and the atom dia 4 atom ni come from yang ni, NH3. There are 1 atom of nitrogen and 3 atom of hydrogen. That's why you dapat 4 atom. So by using calculator, you akan dapat 9.64 times 10 to the power of 34. For empirical formula, kita sepatutnya berhenti di sini lah ya kan. Tapi tak apalah, saya teruskan sekejap ya. For empirical formula, it is the simplest formula that give the number of atoms that present in their smallest whole number ratio. Nisbah yang terkecil. While the molecular formula give actual number of each element in a molecule of compound. It also indicates the correct relative number of atoms. Molecular formula equal to the empirical formula. And empirical formula. Ni. For empirical formula and molecular formula, the mass relationship in the chemical formula with the percent composition from the formula or the number of gram of each element in 100 gram of the compound. So kita calculate dia based on 100% lah. The sum of mass of all elements in a compound are as represented by chemical formula is equal to be 100%. Composition, percentage of composition of element present in a compound, the equal to the number of specific element in the formula times relative atomic mass of 100 divided with the relative molecular mass of the compound. And then the total composition equal to number of specific element in the formula times the relative atomic mass of the total mass divided with the relative molecular mass. And total mole composition, ini formula dia ya. Ini formula yang you perlu familiar with it lah. Familiarize ya. Or you nak hafal ke atau buatlah sesuatu dengannya. Number of specific element in the formula times the relative atomic mass times with total mole divided with relative molecular mass. So, how to use this formula? Itu yang paling pentingnya, menggunakan. If you tahu formula, but you do not know how to use it, sama seperti you tak tahu. For example, simple example over here. Percent composition of chromium in a potassium chromate. Okay. Relative molecular mass of potassium chromate. Yang ni lah. 294. Whereby it come from two of KR plus 2 CR plus 7 oxygen. Okay. So in the bracket tu dia atomic mass lah for individual atom. Okay. For example yang ini potassium lah. You kena tengok periodic table, from there you akan dapat potassium tu berapa nilai dia. And then percent composition dia tu chromium. You tahu chromium dia adalah 52. Okay. Ini bukan duduk di sini, sepatutnya duduk di sini ni. Sepatutnya duduk di situ. Mungkin disebabkan saya guna ada different computer tu, dia ada sedikit lari sedikit. Different software, window berbeza. Okay. 2 times 52 divided with 94 times 100. So di sini you akan dapat percentage dia untuk chromium 35.37%. And then example yang ni, simple example yang ni, calculate the mass of oxygen in gram in 23.5 gram of lithium phosphate.
Boleh nanya, Prof?
Ya, boleh. Tanyalah.
Itu 2 kali 52 tu dari mana datangnya, Prof?
Oh, ya ni. Pasal kita, because, thank you, terima kasih kerana bertanya ni. Because yang ni, soalan ni, saya tukar color sikit ya. Soalan ni, dia bertanya, minta you calculate the percent of mass for chromium. Okay, chromium saja dia nak tengok. Dia minat hanya chromium. You dah manage to calculate relative molecular mass of potassium chromate in the potassium chromate secara keseluruhan dia. So di sini dua ni adalah 2 CR divided with semua yang ni lah. Times 100. Boleh Kalau let's say dia minat pada calculate the percentage composition by mass of oxygen in potassium chromate, berapa dapat? Kita cuba. Cubalah. Saya pun, ini impromptu discussion. Calculate the percent composition by mass of oxygen. In potassium chromate, still using the same compound. Cuma kita tukar di sini, chromium ni, yang ni kita tukar, kita guna oksigen. So sekarang ni, berapa persen dia? Cuba tekan kalkulator, saya pun tekanlah juga kalkulator. Berapa dapat? Saya nak tengok dia punya QR. Mungkin dah ada yang jawab. Berapa dapat untuk tu? Untuk oksigen. Saya harap you all akan dapat 38 point berapa ni? 0.1%. Ada 10% di sini. Baik, saya teruskan . Okay. And untuk example ni, for you try to calculate the mass of oxygen in gram in 23.5 gram of lithium phosphate. Okay. First, you kena tahulah percentage, you kena boleh calculate the relative, relative molecular mass of lithium phosphate. Second, you kena calculate the percentage of oxygen in dan yang ketiga tu baru dah you boleh calculate mass of oxygen. Dapat? Exercise ni you boleh buat sendiri ya. Saya continue ya. Okay. And then in determinations of percentage composition for each element. C2H6 oxygen. Oh. Ni structure of C2H6 oxygen. For the percentage of carbon, because ada 2 carbon, and then times 12 divided with 46, 100% times 100, dapatlah 52, and then hydrogen, percentage of hydrogen, from there you can calculate about 13.04%, and oxygen 34.79%. And bila you add percentage of carbon, hydrogen, and oxygen, it will give you back 100%. Sorry. You akan dapat balik ini 100% ni. Bila you total up the percentage of carbon, percentage of hydrogen, and percentage of oxygen, you akan obtain 100%. Ini kritikal ni. Boleh cuba juga exercise ni. Ini final exercise ni. Selepas ni dah tak ada dah exercise. Jangan risau. Yang ni exercise ni ambil masa sedikit. Ambil masa 15 minit dan siswa semua boleh buat kemudian lah. Saya akan continue supaya kita tak terlalu lama talk ni. Kalau di UiTM ni, peraturan universiti online teaching ni untuk setiap sesi tu paling maksimum 2 jam sahaja. Itu maksimum yang kita boleh buat untuk mengelakkan masalah mata kepada student dan konsentrasi kepada student lah. So later on, kalau you sempat, you boleh belajar berkaitan dengan empirical formula. From mass, you need to convert to moles. By converting the gram to the and divided with the molar mass, dapat mole. Alhamdulillah. Alhamdulillah. And then for moles of each element, you divided it by the smallest number of moles, you dapat the ratio of it. And then you need to change to integer subscript so as it fits empirical formula whole number lah. Tips dia di sini ya. Ini tips di sini, ratio yang digunakan pakai di sini. Di Indonesia, di UIR mungkin berbeza. Yang ni you kena consult with Dr. Muhammad. Okay. Untuk kami di sini 1.9 kita akan round off dia to 2, 1.8, 5.8 to 6, 5.9 pun sama juga become 6, 5.5 times 2 become 11. Okay. 11, 5.6 round into 11 because we times to 2 it become 11.2, so we round it become 11. And the same case with the 5.7, contoh ya, times 2, 11.7, 11.4, sorry, 11.4, so you round off dia, you akan dapat, bulatkan dia, you akan dapat 11. But then untuk 1.5, you times again, come back. Tengok kita concern over here, not 5. Doesn't matter yang di depan ni berapa, 1 ke, 2 ke, 3 ke. But if not 5, we times to 2, which is almost the same as not 5, 5.5 over here. Times to 2, for this case 1.5, kita akan dapat 3. Okay. And then 2.6, just like 2.6, again still we times with 2, 5.2, round off dia, bulatkan dia, dia akan dapat 5, just like yang ini. Okay. Not selepas itu, number and not selepas itu kita tengok berapa kita patut times dia, times 2 or round off ke atau tidak. Ini diguna pakai di list lah. An example dia, a compound contain 62.58% of carbon, 9.63% of hydrogen, and 37.79% of oxygen by mass, with a molecular weight of 230 gram per mole. And then you need to calculate the empirical formula. You can calculate empirical formula dulu and then barulah you boleh calculate the molecular formula of compound. Ini teknik dia, cara simple lah. Okay. Kita guna consideration that yang ni bila percentage dia macam ni, bila dalam percentage kita lihat compound tu adalah 100 gram. So let's say for carbon, if you want to know the mass of carbon in the compound, 62.58 times 100, dia akan dapat balik 62.58 gram. That's why di sini you dapat 62.58, and similar things you can follow the similar step to hydrogen and oxygen. And then for each compound, yang ni saya gemar kepada student saya buat dalam bentuk table supaya senang. Senang, and then student tak buat mistake. Tak perlulah you tulis every single word divided with the mass or number, tak perlu. Just molar mass in gram. Ini first dia, mass in gram. And then the ratio of it and empirical formula. Yang selebih ni hanya untuk kamu faham sahaja. Okay? So, kalau tengok pada molar mass, for carbon, relative atomic mass dia 12. So, bila you divided 62 divided with that 12, dia akan dapat 5.215. And then for hydrogen, satu saja dia punya relative atomic mass dia, 9.63, and mole dia, betul lah mole lah. And for oxygen, 16, 27.79, divided it, you akan dapat 1.7368 mole. Okay. And then from there, you dah dapat dah. Dah calculate for individual element tu, you dah ada for carbon 5.25 mole, for hydrogen 9.63, oxygen 1.7368. From here, you need to take a look or pick up the smallest number. Smallest number adalah 1.7368 lah, 1.7368, and divided it with other. Okay. Use it as a pembawah lah. 1.22 ataupun yang letak situ 1.25 pun boleh. Bahagikan dengan 1.7368, you akan dapat somewhere around 3.005. And then 9.63, you akan dapat 5.5. You akan dapat yang ni dulu. Okay, 5.5. And then for the hydrogen, oxygen, you akan dapat 1. You dapat 1. 3.005, 5.5 for 4, and 1 for the oxygen. From here, hati-hati, you kena tengok between these three elements in the compound, which one not their 0.5, somewhere around 0.5. If they are not 0.5 or 0.6, just like before, okay, 0.5, 0.6, 0.7, ini konsep yang diguna pakai di Perlis. Okay. Di Indonesia mungkin berbeza. Okay. Indonesia mungkin berbeza. So yang ni you kena consult with Dr. Muhammad. Terus kita di sini, kami di sini, bila ada 0.5, we must multiply it with 2. Okay. Bila yang ini dimultiply dengan 2, yang lain pun, section untuk carbon pun dikena multiply by 2, oxygen pun mesti dimultiply by 2 juga. So from here you akan dapat 6 for carbon, 11 for hydrogen, and 2 for oxygen. So its empirical formula akan jadi macam ni. C2H11O, 2 tu di bawah, subscript, oxygen 2. And then to calculate the molecular formula of compound, empirical formula kita dah tahu. Empirical formula 230 ni adalah molecular formula. 230 gram per mole adalah molecular formula of the compound. So untuk tahu berapa sebenarnya apa number dia untuk for each carbon, hydrogen, oxygen for that particular compound, kita gunakan cara ni ya. Yang mana C6H11O2 in bracket tu kita letak simbol N, yang mana times yang tu. Okay. So either you write individually seperti contoh ni, or you can use N 6 carbon plus 11 hydrogen, kata atomic mass of hydrogen, 11 times hydrogen satu je. So tapi tak apalah, boleh jugalah. Plus, tak nampak dah, saya tukar color. Tak nampak juga, kena pakai warna merah. Tu oksigen. Ke tu 230 gram per mole. So from there you akan dapat di sini adalah 115. So then you boleh tukar balik ke sini. (150) N equal to 230. So N equal to 2. So the real formula for the compound or the molecular formula adalah C12H22O4. From the experimentations, you can give the data that will lead you to determinations of formula of the compound through mass of element in a compound, mass percent in a compound, and masses of product obtained from the reactions by weight sample of the compound in the case of combustion process. This is another example whereby 5 gram of acetic acid are burned in air, 7.33 gram of CO2, carbon dioxide, and 3 gram of water are obtained. And then you need to calculate the empirical formula for acetic acid. Ini example dia lah. From CO2, you can determine the mass of carbon. Okay. Let's say lah, in the case you all tak tahu acetic acid ni macam mana. Bilangan carbon, hydrogen, oksigen, CHO dia, tak pasti. So secara ni you boleh pakai CO2, you tahu hasil sahaja. Maklumat yang ada hasil sahaja. So from CO2, you can calculate the percent of carbon or determine the mass of carbon. Okay. Times 12, you akan dapat 1.999 gram for carbon. Okay. Jangan bundarkan lagi. And then for H2O, this is a two product of it. Adalah 2 hydrogen. Ini persen per element per molecule. Percent element per molecules. Times 3 divided with 18. Okay. 3 because this 18 come from, reactive molecular mass of water. And then times 1 gram, you akan dapat 0.3333 gram of hydrogen. So from there, you boleh postulate that the mass of oxygen equal to the mass of the sample minus mass of, in bracket lah, mass of carbon plus the mass of hydrogen. So mass of oxygen, you akan dapat 2.668. And from there, barulah you need to start from the hydrogen, from the gram, kata telinga, sorry ya, dah lama dekat telinga. Empirical formula, from the gram first, and then go to the mole. You need to calculate number of mole for each element in the compound, and then get the smaller ratio of it based on, by dividing with the smallest number of mole between the three elements. So you need to identify lah from here mana satu elemen with the number of mole yang paling kecil sekali. So ini kita dapat carbon lah, paling kecil. So by dividing with the mole of carbon, you akan dapat somewhere around 1.001, 2.008, and then 1.001. All of it, you can bundarkan dia, make it round number. For carbon become 1, hydrogen become 2, and oxygen 1. So empirical formula dia adalah yang ini. This is the empirical formula. Alhamdulillah. Terima kasih semua. Tapi sebelum tu saya nak minta bantuan sedikit. Ini untuk feedback kepada saya supaya saya tahu apa yang perlu ditambah baik selepas ini. So saya harapkan pada masa sama you buat survey monkey ni, survey sedikit, feedback sedikit, and then attendance untuk saya tengok saja. So I open for Q&A lah, questions lah, section. Boleh ke Dr. Muhammad? Okey ke?
Ya, silakan Prof. Maybe dalam 10 menit saja ya kita buka.
Ikutlah, saya tak ada masalah.
Biar Profnya tak capek sangat. Oke, silakan pada mahasiswa. Saya berikan waktu.
Nak tanya soalan apa saja pun boleh juga. Kita dah hampir 2 jam lebih kita kan?
Dah lebih. Ya.
Dah lebih 2 jam lebih. Memang kalau lama-lama memang fatigue. Letih.
Iya, fatigue.
Di UiTM kita tak bagi, dan arahan dia daripada universiti seboleh-bolehnya kalau kelas tu face to face 1 jam, online ni 15 minit saja.
Ya benar, di tempat kami hanya 40 minutes.
Sama saja ya?
Prof. Ya sama saja,
ya,
40 menit saja.
40 minit, 15 minit saja. Kita kena compress dia jadi 15 minit kan?
Ya benar. Tapi tetap muka dengan video conference dengan Prof sekarang ini bisa untuk artinya membawa sampai ke materi atau topik Avogadro minggu lepas atau 2 minggu lepas begitu.
Oh dah. Minggu lepas dah masuk dah ni ya?
Ya Prof.
Oh okey. Because di Perlis ni bila kita belajar berkaitan dengan atom, dengan atomic structure ni, kita very concerned on the Avogadro number, empirical formula dengan formula lah. molecular formula. Iaitu banyak sekali soalan ditanya di sini lah. Itu di sini
Iya.
lah.
Mungkin kepada mahasiswa ada yang tanyakan?
Atau dah letih dah.
Salah satu kemungkinan, Prof.
Ya betul, biasalah tu. Dia kekurangan menggunakan online ni biasanya kita akan sakit mata.
Ya, benar.
Kita tengok skrin dan kita akan sakit mata. Mata saya sendiri pun sakit juga.
Masalah jaringan sih, Pak.
Oh, begitu ya. Kalau terkait tema apa? Topik kita hari ini.
Ya?
Ya, mahasiswanya, Prof.
Okey. Saya tukar kepada yang ni lah.
Apakah tidak ada pertanyaan kepada mahasiswa? Aduh, mungkin sudah letih ini, Prof.
Ya, saya faham. Tak apalah. Saya bagi pertanyaan untuk diri saya sendiri yang ramai student tanya. Doktor dah kahwin ke belum? Ini biasalah student tanya. Jawapan saya sudah ada isteri.
Okey.
Tapi ada satu sajalah. Tak berani ambil 3.
Ya, tak berani. Iya.
Anak berapa, Prof?
Anak tak ada lagi, tak ada rezeki lagi. Belum
Oh,
sampai lagi.
belum dapat rezeki ya, Prof ya.
Ya, belum rezekinya lagi.
Iya. Oke. Rezekinya mungkin masih mengajar gitu.
Ya, betul. Rezeki saya masih di tangan student saya lagi, you all lagi.
Oke, siap, Prof. Oke, kepada mahasiswa ada yang tanyakan?
Alhamdulillah, terima kasih Aldo. Doa tu, terima kasih.
Mungkin itu saja mungkin, Prof. Kalau memang materi atau topiknya sudah habis, mungkin kita bisa tutup acara kita.
Ya, tu. Saya kembalikan kepada doktor lah.
Mungkin ada closing statement dari Prof. Razib atau
Okey.
pesan untuk mahasiswa.
Kepada mahasiswa UIR ini,
Ya.
kelemahan student saya tak pasti kelemahan student UIR macam mana. Basic chemistry ni kebiasaan student tidak kuat. Jadi apabila kamu belajar makin subjek yang makin ke hadapan, basic ni kamu lupa. Dan di situ dia akan jadi accumulate yang mana result kamu makin lama makin rendah cumulative grade kamu. So sangat kritikal untuk you faham basic chemistry. Ambillah masa untuk memahami dia. Dia tak susah dan sangat diperlukan. Dan semoga berjaya dalam you punya kejayaan kamu, degree kamu, dan tolong jaga kesihatan. Di sini kita panggil PKP untuk hindarkan atau try to stop transitions of COVID lah. Itu saja daripada saya. Terima kasih.
Oke, terima kasih Prof. Razib atas waktunya. Pesan buat kita semua seperti yang disampaikan oleh Prof. Razib. Hendaknya untuk basic knowledge kita seperti kalkulus, fisika, kimia harus benar-benar bisa kita kuasai agar kedepannya untuk advanced knowledge-nya dalam perkuliahan ke depannya sehingga menyelesaikan kuliah itu bisa mudah ketika basic sudah kita kuasai. Mungkin itu. Mungkin itu saja, Prof. Saya tutup. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Terima kasih, Prof.
Ya, sama-sama.
See you next time.
See you. Salam semua.
Alhamdulillah, terima kasih.
Sudah zuhur di sana, Prof ya? Oke, mungkin saya tutup ya, Prof ya. Saya
Oh iya, betul. Sama-sama.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.